Okay, this is number 63. Just going to do a little bit more review with graphing quadratics and solving exponents. Okay, so let's get into it. So I've been saying in the other videos how you have to really do GCFs first. So we've seen these on both 61 and 62, that you want to always see if there's something that goes into all the terms, or in this case both terms, take that out first. So in this case, there's an x in both of them, so the first thing you want to do is take that x out. That will help you. So do that first, and then you can solve it. So we'll have x equals 0, and x plus 4 equals 0. And when you solve that, you get x equals negative 4. Okay, so our two x-intercepts are 0 and negative 4. And it might be tempting to look at this and say, well, that's a perfect square, and you can do, x plus 2, x minus 2. But remember, for this to work, this has to be subtraction, and you can't have an x here. So it's a small detail. It looks like one of those perfect squares, but it's not. You cannot do that. So do the GCF first, and then you'll see what's left over. Oh, it's x plus 4, not x squared, and you won't even try that. So the GCF will kind of help you go in the right direction. So we have 0 and negative 4. So there you go. That's also going to be our y-intercept, right? Because there's like a plus 0 on the end, so our y-intercept is 0 as well. So one of our x-intercepts and y-intercepts are the same, which means it's at the origin. All right, so we have negative 4 as well. 1, 2, 3, 4, with the axis of symmetry right down the middle somewhere, right? And negative 2. Now there was a formula for axis of symmetry. It was negative b over 2a. And you could use that as well. You'd have negative 4 over 2 times 1. And that gives you negative 2 as well. So either way, you can get this, the axis of symmetry from the graph or from the formula, two ways. But if you don't have a graph, you really want to use the formula. Okay? So the vertex is going to be negative 2 comma something, and just plug it back in into here. So we'll have negative 2 for x. So it'll be negative 2 times 4 minus 2, which is 2. We'll get negative 4. So we know the vertex is at negative 2 comma 1, 2, 3, negative 4 right here. And that's good enough for our graph right now. If you want to plug in more numbers and do a table, you can be more precise, but this is going to be good enough. Okay? And once again, we got a min, right? Because the graph opens up, the vertex is a minimum. So you can say because a is positive or because the graph opens up. And that's another way of saying positive, right? If it's greater than 0, it's a positive number. All right, so let's look at number 2. Just do more practice with the exponents. Remember, you can always write these out the long way, and it might take a while, but you'll probably get the right answer. So I'll do one of them the long way, right? Just to show that, yeah, it takes some time, but it's going to get you the right answer. 4, 5, 6, right? And then let's make those black. And then we have times negative 3, and then we have 8 x's. Right? I'm just going to write these 1, 2, 3, 4, 5, 6, 7, and 8, and 5 y's. 1, 2, 3, 4, 5. So how many, what numbers do we have total? Well, negative 4 times negative 3 is just positive 12. For the x's, we have 4 here, we have 8 here, so altogether there are 12. And for the y's, we have 5 here, and we have 6 here, and we have 5 here, so that's 11 y's total. There's your final answer. And of course, you can get those just by adding those exponents up. Number 3, more of the same, just with division. So reduce negative 6/8. Right, you'll get negative 3/4. Okay. We have 5 x's on top, 2 on the bottom, so these two will cancel out 2 of these on top. You'll be left with 3 of them. All right, now here we have a negative exponent, which means you just move it to the top. Negative exponent, it means you move it to the top, and it'll be a positive exponent up there. So we really have 4 y's on top, and now 3 more on top, so 7 altogether on top. So negative exponent is not a negative number. It just means it's a fraction. We got to move it around a little bit. Your final answers should never have negative exponents. So I can tell this is finished because there are no negative exponents and I don't have the same variable on the top and bottom, and my fraction is all fully reduced. Okay. Be careful on these that it might be tempting to make this 1 over, like say this is it's a negative exponent, you got to move it to the bottom, but it's really only the part that has the exponent is really the only part that moves. So the 7 stays there. So it's really going to be 7 over x to the third. Only that x to the third is going to move to the bottom. So that's why that looks simple, but it's a common mistake, so just threw that in there just to make sure. Okay, we're going to do third roots. So remember, a third root is like what times itself 3 times would be like 27. So you're looking at 3 multiplications to get 27. That's the idea. So here, it's what multiplied times itself 3 times is this negative 64 x to the 6th, y to the 15th. Now, it looks intimidating. It's easier than you think. So just break it up into pieces. What times itself 3 times is negative 64. And you could say, well, 2 times 2 times 2, well, that's 8. 3 times 3 times 3, we know is 27. And then you get to 4. 4 times 4 times 4 is 64, right? And now, since it's negative, we want these to be negative. So yeah, just break it up one by one. What times itself 3 times is x to the 6th, right? So it's got to be, if you do x to the 1 only, you'll get 3 total, right? 1 plus 1 plus 1 is 3. So that can't be it. And then you try, well, 2. 2 plus 2 plus 2, well, that's 6. So there you go. That's it. And then finally, do the same thing for the y's. Y to what will give you, times itself 3 times gives you 15. And you could try, 3, 3, and 3, right? That'd be 3, 3, and 3. That only gives us 9. We need to get to 15. So back it up. And let's try 4, 4, and 4, or eventually you'll get to 5, 5, and 5, which add up to 15. So your answer is really just one of these. And you don't put all of them. Okay, so your final answer is just negative 4, x to the 2nd, y to the 5th. Okay, so that's what it means to take a third root. So if I just multiply this 3 times by itself, I would get what's inside here. Okay, let's go over the back, number 6. All right, just remember that 1/2, this is the same as a square root. So the square root, that's a 2. Square root of 25 is just 5. 25 to the 1/2 power is 5. Same exact meaning. Okay. You could also do 25 to the 0.5. So if your calculator didn't have a square root button, but it did have an exponent button, you can still take square roots by typing in 25 to the 0.5 power. All right, so now when we have a numerator and denominator, right, we're still going to do the same thing with the bottom number, right? This tells us what times itself 3 times is 27. So in effect, we kind of do this. We break it up into 2 parts. We say what times itself 3 times is 27, and then take that answer and take it to the second power. So we just really broke up the fraction into 2 parts. Take that a 1 and just pulled that 2 out. Did in 2 steps instead of 1. Okay, so 27 to the 1/3 power. So what times itself 3 times, right? 3 times equals 27. We did that earlier. You get 3. So 3 times 3 times 3 is 27. And now we raise that to the second power, so you get 9. All right, let's go down to number 8. Same thing, a little more practice with these fraction exponents. So we have 16, and again, break it up, but that 4th root first, so 1 over 4, and just you're pulling out that 3 to do that second. Do that later. So what times itself 4 times is 16, and eventually you'll end up with, well, that's 2. 2 times 2 times 2 times 2 is 16. and then take 2 and raise that to the third power. So 2 times 2 times 2 is 8. All right, number 9. Again, one of those problems that looks more intimidating than it really is. Now, you might have noticed on that last problem, we go back up here to number, I think that's 5. It lets me. Oh, there it is, number 5. So you might have noticed that there's a pattern here. We didn't really look at it here, but it was really, if you take 6 and divide it by 3, you get the 2, right, that we eventually got, the 2. And if you take the 15 and you divide that by 3, you get the 5. So we did this a long way and kind of showed a lot of work, but it really wasn't that bad. So this just comes down to a lot of symbols, but in the end, the answer was, do you know how to do basic elementary school division? 6 divided by 3 and get 2, and 15 divided by 3 and get 5. So not that bad. You still have to know how to do the cube root of negative 64, but the exponents are actually the easy part. The hardest part is the number. So going back down here, let's just use that. 20 divided by 4, right, is 5. And 16 divided by 4 is 4. Not too bad, right? And then 12 divided by 4 is 3. And 24 divided by 4 is 8. Now we still need to reduce this because you have the same variable on the top and bottom. So let's look at these individually. So we have 3 x's on the bottom, 5 on top. So 3 of these will cancel out 3 of these, leaving you with only 2 left over on top. Right. And in the same way, we have 4 y's on top, 8 on the bottom. So these 4 will cancel out with 4 of these, leaving you with 4. So we got y to the 4th on the bottom. So again, it looks intimidating with all these square roots and there's 4 in there. You're not used to seeing that. But in the end, it's a lot faster than you think. All right, let's go down and solve some equations here. So the idea here is you want these to be the same bases. Now this is called the base, and that's called the exponent. So you want these two numbers to be the same. You want them to match. So usually you go down in numbers. So the bigger number you want to rewrite as a smaller number. So can you write 81 as 3 to some power? So 3 times 3, how many times, right, will give you 81. Eventually you'll get, 3 to the 4th power is 81, because 3 times 3 times 3 times 3 is 81. And there your answer is right there. We know that x is our answer, the exponent, so it's 4. We get x equals 4. Right. It's a long way of asking 3 to what power is 81? 3 to the 4th power is 81. Now we get to here, we don't want to go straight to writing this as a power of 4 because we have this coefficient. So just divide that coefficient out first, that's 3. Remember, the 3 is not being raised to the x power. That's only this that it's attached to. So we can do this. So 4 to what power equals 48 divided by 3 is 16, which is kind of a no-brainer question, but yeah, 4 to what power is 16? Well, you guys already know. Yeah, 4 to the 2nd power is 16. So x equals 2. Okay, there we go. All right, that's the end of number 3. Again, you want to be able to do this entire review by yourself along with the other ones with no help and get 100% showing all the work. Okay, and that way you know you're ready for the finals. Many times as it takes, redo it over and over until you can do it all by yourself. All right, good luck.